Okay, for the dot product, you may say, why do we do this? Okay. Like I said, math is about the operations. I mean, how do we come? How do we do operations? Okay, so we already studied how to compute the addition, difference, and the scalar multiplication. For the scalar multiplication, it's a number multiplied by alpha. Now we didn't talk about how to multiply, multiply two vectors, right? There are many generalizations, but now we are talking about dot product. So the definition is of dot product, or there are many names in the product. Okay, anyways, that's why you can use anyone, because I would like to use the inner product in the book. It also talks about the inner product. Right? It also say, okay, sometimes the people call it the inner product, but by my experience, the students like the dot product. Okay, so alpha is x1, y1, z1, beta is x2, y2, z2, and we write alpha dot. Maybe that's a reason. Okay, this, and then this is, what's this? The definition. Okay, if it's a definition, I write this, means a definition. Or some people use equal to dot. Anyway, x1, x2 plus y1, y2 plus z1, z2. This is also definition and also a formula. Yeah. You have to remember it. So you have to be careful. So you have to be careful here. Okay. Remark. The product, we're saying the dot product is product. Means that we call this the product, right? Is a scalar. Oh, scalar. Oh, that's very right. And not right. Is a scalar. Anyway, why do we say this? Because this is a vector. You may say, why do you emphasize? By my experience, always there are some students making mistake on this. Anyway, so it's a number. Anyway, for this, we have following property. You have to know this. So if we have an alpha, this is x, y, z. So I just write this one. And the beta is x2, y2, z2. For this, we know alpha dot alpha is the length of alpha. Or sometimes the people, they are the same. Alpha, the length is like this. We already know the length, right? You can say, oh, if I go back, it takes time. Length, where? Here, you say? Right, just a definition. Here, it's the same, you just put them together. Okay, this one, what's the second one? Is maybe we have a gamma is x3, y3, z3, and the alpha dot this gamma is alpha dot beta plus alpha dot beta. This is what's this? This is called distribution, right? In your, I think distribution in your elementary school. No, maybe in US in high school. Okay, I'm not sure. Okay, anyway, the third one is alpha dot beta is beta dot alpha. This is called the commutative law. So means that you order the, switch the order of the vector. The product is the same. For example, in your high school, no, not high school. Anyway, we know this. 1 multiplied by 2 is 2 multiplied by 1, like that. You can say, well, just generate what we knew in our high school. Okay. And 4, so we have lambda, alpha, and beta, vector multiply vector. This is lambda, alpha dot beta. This is a scalar multiplication. This is dot product. This is dot product. This is scalar multiplication, or this is alpha dot product lambda beta. For any lambda is scalar. Okay, what's it? Lambda is R. So let's look at the last one. Look at the last one. If we have 0, I think I made a mistake in my lecture notes. What happened? Okay, if 0. Oh, sorry, I didn't make this mistake. I emphasize here. It's a vector alpha. 0 is a vector. Now, you may say, why do you add an arrow? Okay, I will explain why. This is 0. It's a number. This is a scalar. This is a vector. Compared to this, we have 0 is a number. We modify, no, scalar multiplied by a vector, we get a 0 vector. Is it clear? Anyway, that's fine. So this is about the scalar multiplication. So you may say, okay, why do you understand? Why do you introduce this? Because the dot product has many geometric meaning. So let's explain it. So the first one is a theorem, where it's also a formula. Okay. General theorem is very important. So if we have alpha multiplied by beta, no, dot product beta, there is a formula like that. This is alpha, the length, beta length times cosine theta. Or sometimes the people write a cosine theta is alpha, beta, and alpha, beta. So you may, what's theta? So here, theta is the angle between alpha and beta. So this is alpha, this is beta, and this is theta. So it's kind of a formula, right? So if we know two vectors, you can compute the angle by this formula. Or if you know length, you know the angle, you know the dot product. If you know the dot product, you know the angle, you can know the multiplication of, the length of alpha multiplied by the product of the length of alpha and the beta. Okay, so this is the kind of, about the geometric meaning. You have to know this, or this is the formula. Okay, I just, theorem and formulas are the same. They are all important. Okay, so and then let's look at more examples. So the first one, if we alpha is 4, length is beta, its length is 6. The angle of alpha and beta, the angle between alpha and beta is pi over 3. Oh, why is the color? Anyway, sorry, I forgot to change. Anyway, the color should be black. So, and then what's this? What's alpha dot beta? Alpha dot beta is this cosine theta. So this is 4 multiplied by 6, and the cosine this, and the 20, the 24 this. What's this? This is half. So the answer is 2. Okay, so this is about this example. And then example 2. For another example, if we have alpha, this is 2, -1, beta is 5, -3, 2. So what's the angle between alpha and beta? Probably cosine theta is alpha dot beta, alpha length multiplied by length of beta. So means that you have to first compute this. How do we compute this? This is 2 multiplied by 5 is 10 plus 2 multiplied by this is -6 and plus -2. So we get a 10 minus 8 is 2, right? I hope it's, yeah, I hope it's right. So what's this? This is 4 plus 4 plus 1 is 3. Beta is 25 plus 9 plus 4, right? What's this? Right? And then I hope in the test you can write it in my way, because if you write it in my way, it's easier to get the partial score, because sometimes the student just write everything together, you know. It's hard to pick the, you know, the point that I can give it a score. You write everything, okay, I know this, I just made a mistake somewhere. And then this is alpha dot beta, alpha divided by length of alpha times the beta. So this is 2 over 3, like this. Okay, you can write cosine theta is 2 and this. And you use your calculator, write theta is arc cosine like this. You use your calculator, get the number, clear? Using, because if in a test we have a problem like this, you just use your calculator to find the arc, that number. Anyway, that's fine. So we still have 15 minutes. Okay, sorry. Because I change colors so frequently at the beginning, waste a lot of time. So, and then let's tell you some remark. This remark is very powerful. Geometrically, we have 2 vector alpha. We say, okay, we say, sorry. We say alpha is perpendicular to beta or orthogonal, or orthogonal or perpendicular. We say alpha beta. This is the definition. We say alpha. This means alpha is orthogonal to beta. Okay, or alpha is perpendicular to beta, or when you say the angle theta is pi. I think you know this in your high school, right? We have 2 vector, or you know, we have 2 vector alpha and beta like this. We say they are perpendicular to each other if the angle is pi over 2 or right angle, right? So if we know this, it's very easy for us to know 2 vectors are algebraically are perpendicular. No, okay. From this, and then let's look at the cosine theta is alpha, beta, and alpha, beta. From this, it tells us alpha is perpendicular to beta. In general, we use this. This is the rotation. If and only if alpha dot product is beta. This is kind of geometry, right? Geometry is easier to help you say their position, but it's hard to say something. 2 vectors are, you know, precisely perpendicular to others. Maybe a little bit, but just not perpendicular to others. But it means that, okay, how do we know it? Algebraically. say, compute this. If the dot product is 0, means that they're perpendicular to each other. Clear? Okay. So let's look at an example. So if we have alpha is 2, negative 5, beta is 5, negative 2, and 2, the problem is that 2 alpha is perpendicular to beta. Right. By what I said, if when you prove 2 vectors are perpendicular to each other, what do we do? So you compute this. You can say this is 2 multiplied by 5 plus 2 multiplied by negative 5 plus negative 5 multiplied by 2. Right? 2 negative 5, 2 negative 5, 5 negative 2. Okay, so we get a 10 minus 8. Oh, sorry, I made some mistake. Oh, I made a mistake. I think this should be 1. I think in the lecture notes, I made a mistake. Okay. Say lecture notes. Say no. Okay. So by 2 is 0. Anyway, sometimes, when I copy them, the number just wrong. And then we obtained alpha perpendicular to beta. Okay, we still have time. Last one is about the projection. So this is very important. I think it should be in a quiz, right? Projection. So if we have like this is beta, this is alpha, right? So what's the projection? You just from this point, or you may say this is A, this is B, this is C. We project the vector A, B, right? Where alpha to beta, beta is AC. Project this on to or on to AC. We get a right angle. We know now, let me change the color. Sometimes I have to. This is theta, right? We know how to compute this, right? If we know this and know now we just try to compute the projection of alpha to beta. This is the rotation. How do we compute the vector? If we want to know the vector, you have to know the length, right? So we already know the direction is AC, right? So, and how do we know it? So we know theta. Cosine theta should be alpha dot beta this by the formula, right? And then we know this should be AB, the length, times cosine theta. This is the triangle information you know in your high school. Okay, and then we know now AB is alpha. Alpha length. No, here, sorry. I made a mistake. So first, let's compute. This is D. So let's compute the AD. Sorry. AD, the length. Okay, just the length. So the length is AB cosine theta. This is alpha multiplied by alpha beta like this. So we get alpha beta like this. So we get the length of this part is alpha dot beta over, beta. Right, this is the length, but we need a vector. We already knew the length, right? How do we find the vector? So the vector should be alpha dot beta. This is the length, beta, and multiply by the unit vector of AC. The unit vector of AC is beta over this. So the formula in the textbook is alpha dot beta. You have to add this one, it's a number, multiplied by beta over beta squared. Okay. Formula projection beta alpha is alpha dot beta and beta over beta squared. So you have to know this. For the projection, you have to know the formula. Okay. This is very important for us. Okay. So we still have time. Let me give you an example. Okay, let's first give you an example and then try to explain more if we still have time. Oh, of course, if we don't have enough time, okay, let's stop here. Okay. So let's look at the, okay, example. Alpha is 2, 2, 1, and beta is -2, 3, 1. So compute this. So this is just alpha dot beta and beta over beta squared. So means that you have to compute this and this. So let's first compute alpha dot beta. Alpha dot beta is -2 plus 3 plus 2. So the answer is 3. And also you have to compute the beta squared. Beta squared, just, we know the formula for the beta, the length of beta. You just, square each component and add them together. Is 4 plus 9 plus 1 is 14. So we come back here. So we get this is 3 beta. You just like this and over the number. And then you simplify it, you get 14 -6. Right? And no, 9. Right. Hence, the projection beta alpha is this 9 over 14, 3 over 14. Is it clear? So I think this is just what I prepared for today's class. And then maybe I should add something. We still have 4 minutes. So I write a remark. So for the dot product, you can say, so alpha dot beta is alpha this cosine theta. So if we assume the length of beta is 1, you can say alpha beta is just cosine theta. So if we look at the picture, this is beta, this is alpha, this is beta, this is alpha, this is a projection, right? We can say the length of alpha multiplied by the theta. You get this is the length of this part. From this, we can say, from this perspective, we can say the dot product is just projection. If we only look at the scalar, you can understand it in this way. It doesn't mean they are the same, right? It just tell you something interesting. Okay. I think today I'm done.